Welcome everybody. 4.1 videos do this. Please title it Using Graphs to Relate to Quantities. So today our objective is to represent mathematical relationships using graphs. Okay, let's take a look at this little thing right here. You don't have to write this piece down, but I think it's pretty interesting. The graph below relates the height of the water to the volume of the water in each container. Okay, so here's how tall it is, and here's the volume. The volume is how much it will hold, the height is how tall it is. Which graph goes with each container to justify your reason? Okay, so very interesting graphs here. One, this is linear, meaning it's a line. This one's linear, it's a straight line. This is non-linear because it goes straight and then it curves. So what I'd like you to do is to think for a second, pause the video, and think if you can get this right. So pause the video. Okay, assume you pause it. Now let's go ahead and talk about it. So first of all, which one do you think has the most volume? Well, probably the biggest one over here has the most volume. Notice the volume and height go up perfectly, but then the height teeters out, yet the volume keeps increasing quickly. That would be this guy and this guy are matched. And the reason why is because as we get to this top portion, the shape changes where it can start holding more volume with less height. Next, okay, let's do a different color. This volume and height goes up increasingly, but it is a smaller and fatter one. Okay? And this one goes up height quickly with volume, and we get this one. Okay? Alright, let's go ahead and get into some examples. Okay, what are the variables in the graph? Describe how the variables are related at various points. Okay, so we're talking about board length, the length over time. Okay? So, what are the variables that we could be talking about? Alright, one moment. Alright, scratch that last one. I didn't want that. Do that one. I want to do this one. I apologize. Alright, the graph shows the volume of the air in a balloon as you blow it up until it pops. What are the variables? Describe how they related at various points in the graph. Okay, so you have a little balloon that has no volume. Okay, sorry, like I was saying. You have a balloon and it's really small, no volume. Then you start blowing it up. Notice that I take a break, okay? As time ticks, these moments right here, the volume is not increasing. And why is that? Notice I'm taking a breath. When I take a breath, the volume of the balloon doesn't get any bigger, so the volume stays constant. Notice it doesn't get any larger, it's flat, but time is always going on. And then I blow up, pop. The volume instantly goes to zero, okay? Because it no longer holds anything at all. Alright? So we are trying to look at the relationship between graphs and how they're affected on their two variables, volume and time. We blow it up, take a breath, volume stays constant. And we're there. Alright, let's continue. So please go ahead and write this down right here, and we're going to write this in here. These right here, we were what? Breathing. That's a bell, so you should get to class. I can't write right now on here. Breathing. And then right here, it popped. Okay? Boop. Okay, make sure you write this problem out, number 2. Which graph could represent the data shown on the table? Okay? So we have 0 and 5, 1 and 4.8, 2 and 4.6, and 3 and 4.4. So each time we go up 1, notice I'm going down by 0.2, minus 0.2. Each time. Okay? That would be a consistent rate. I start and I consistently go down. Notice that this is a linear progression. See how this curves down? And this one is also linear, but it's going very slowly. Okay? I never hit 0, so this graph hits 0, so this graph would not make sense. Over here, I don't go down faster as we go. I consistently stay the same. But this one stays at a consistent rate and it goes down very slowly. So C would be our best answer. Let's look at one more problem. All right, suppose you're on a swing and you start swinging yourself on a playground. You move back and forth and swing higher in the air. Then you slowly swing to a stop. Sketch a graph what would represent your height from the ground might change over time. Okay, so time we always like to put as our horizontal axis. We call this the, not the y, the x-axis. Okay, and then this is the y. So do you start on the ground? No, you're on a swing. So you're probably going to start a little up high. You're not going to be at 0. Okay? And then you're going to go ahead and swing up, but then you're going to come back down. You always come back down where you start because that's where a swing is. So you're going whoom, whoom. So you should be doing these cyclical things, but every time you're going to go up a little bit higher, and then you're going to do the same thing and you're going to come back down until you stop. So you're kind of going up and down, up and down. And this is when you're swinging up, you come to the very highest point of that first swing, you come back down to where you started, and then you go up high to the back part, and up and down and up and down. So we're going to get some practice with this. It's kind of difficult to really say, hey, this is how you always do it, but you just kind of got to think about how this is going to work over time. All right? Toodles.